Hello! In this video, we present the retrosynthesis of Perampanel, which is labeled with carbon-11, a radiopharmaceutical that is useful in positron emission tomography for the investigation of epilepsy. The retrosynthesis commences considering the incorporation of the cyano group, which has been specifically labeled with this particular radioisotope, through the reaction of an aryl boronic compound with potassium cyanide, which is labeled with carbon-11, serving as the source for this particular radioisotope. The precursor can be synthesized through a sequence of coupling reactions, starting from commercial available raw materials, as we will see later. The cyano group, which is incorporated into the drug, is considered a retrone, and, based on a cross-coupling reaction, a carbon-carbon disconnection yields boronic derivative 2 and the labeled potassium cyanide. As the source of the radioisotope and raw material, the heterocycle, which contains a boron atom, functions as a retron, and a carbon-boron disconnection then generates the substituted bromobenzene, compound 4, along with reagent 5, which serves as a raw material. At this step, a tri-substituted pyridone with aromatic groups, compound 4, has been reached. And based on coupling reactions, by employing a series of these reactions, the subsequent disconnections that we will now describe are specifically intended to detach every single aromatic group that constitutes this precursor. Thus, a carbon-carbon disconnection yields the disubstituted bromopyridone 6 and bromophenylboronic acid 7 as a raw material. A carbon-bromine disconnection in 6, based on a bromination reaction, leads to the disubstituted pyridone 8. Next, taking into account an Ullmann reaction, a carbon-nitrogen disconnection generates monosubstituted pyridone 9 along with phenylboronic acid as a raw material. The pyridine ring in 9 functions as a retron, and a carbon-carbon disconnection based on a Suzuki coupling reaction generates pyridone 11 and 2-bromopyridine 12. The heterocycle in 11 can be incorporated into bromopyridone 13 by utilizing reagent 5. Pyridone 13 exists in a tautomeric equilibrium with hydroxypyridine 14. Thus, a functional group transformation generates bromo-methoxypyridine 15. A carbon-bromine disconnection in 15 gives rise to methoxypyridine 16 as a raw material. Bromophenylboronic acid 7 can be derived from bromophenyldioxyborylane 17. The boron-containing heterocycle can be incorporated into the benzene ring through a coupling reaction between dibromobenzene 18 as a raw material and reagent 5. Finally, the 2-bromopyridine 12 can be derived from the regioselective bromination of pyridine 19, which is used as a raw material. In summary, here are the main disconnections. In the following video, the resulting synthesis will be presented.